In this lecture, we'll explore troubleshooting common network issues. These are the three main scenarios that we'll be looking at: troubleshooting common wired connectivity, wireless connectivity, and just common network service issues. These should be somewhat of a recap for you because these should be in the concepts that you either learned here or in an earlier class. Let's look at the wired connectivity and performance issues. Attenuation is the weakening of the signal because it travels long distances. So you can use a cable tester to see if the signal is weak or if the cable length is too long. The UTP cable has 4 twisted pairs of wire. So the crosstalk happens if one of the pairs are somehow communicating with the other pair. So there is an interference there. So that's when you'll need to check if there's a damage to that cable. Latency is the delay between the time that the sending machine sends a signal or a message and the receiving machine actually receives it and starts processing. If that's too long, then that's usually caused by bandwidth issues. Jitter is when the latency goes up and down quite a bit. So typically you can notice this in streaming applications like video and audio, where you can see there are spikes. So if there are too many spikes and you're doing voice over IP, then you'll need to make sure that you're using some sort of a QoS system. EMI, so this is for coax cables that might be getting interference from the electromagnetic interference, or EMI. So this can even cause a lot of problems or even shut down the network. So this is when you want to use the twisted pair with the shield, so shielded twisted pair STP instead of the UTP. Open short and bent pins, working with the bad copper wire where you have different bent pins on the RJ45 or on the jack. Then you want to check to see if there are any open or shorts. We saw these in the cabling, the different issues with those, so you have to examine those and make sure that the cables are fine. Incorrect cable type. The cable from the wall to the workstations might be bad or might be a crossover cable instead of the straight through cable. Bad port. So if your system is not connecting to the network, then you want to make sure that the port itself is not broken, so you can plug in a different device or something that's actually known to be good to make sure that the port is good. TX-RX reverse. So this is when you're using a punch down tool to connect the UTP cables on a 110 block. You want to make sure that the wires are according to the correct standard, which should be the TIA EIA 568A or B. If you don't, then that might end up with swapping and sending the receiving wires. In that case, there will be a reverse with the TX and RX. Duplex speed mismatch. Usually the network cards these days and network devices are automatically able to detect this, and they're automatically able to use the correct version of the speed as well as the duplex. So this shouldn't really be an issue, but you want to check for that. Damaged cables. We saw this in the cabling, the different types of damage. Could be physical or it could be logical. Bottlenecks. This is where you can see if there are any devices that are causing a lot of traffic on the network. You can also use performance monitoring software to find the bottlenecks. Vlan mismatch. This is a misconfiguration of the switch that's being used for VLANs. So if you allocated certain ports on that VLAN for different networks and you're plugging in the device into the wrong network that it was configured for, then there's going to be a mismatch. And the LED status indicators are the ones with the orange or the green lights that you see on the network card. For the link light should be solid green. Communication light should be blinking green or amber. So this could be an issue if it's amber. Now with wireless, you have reflection, which is caused by light that's bouncing off the objects. Refraction is when there is some sort of a glass and the light goes through it. Absorption is when the light passing through an object is getting absorbed. so the signal gets weak, and in this case you may want to use a multi-path. The latency, jitter, and attenuation, so these are the same as for the wired connections. Incorrect antenna type, so if you have a lot of 802.11 access points, then you want to make sure that, and you're switching the actual antennas for those, make sure you have the correct type of antenna and you have it in the correct direction, which is also part of the antenna placement. Interference, so this is a big one. So this actually has to do with the different channels that you want to use. So you have to use either 1, 6, or 11 so that there's no overlap. And you want to avoid 2.4, but you may need to still use 2.4 because there might be some devices that are still using the older 2.4 megahertz or gigahertz channel. However, that has a lot of interference from the different household or regular equipment. You can use the Wi-Fi analyzer or a third-party RF scanner to actually look for different frequencies and how the actual landscape looks like. Overcapacity is usually when there are too many devices that are connecting to the wireless access point. So this is something that you can actually look for on the actual, by analyzing the access point, the logs, or look for bandwidth saturation. Distance limitation. Wireless networking speeds range from 2 Mbps to a theoretical 1 Gbps, that's for 802.11 AC. The speed is affected by the distance between the wireless nodes. So there's also interference and the other devices, bay monitors and all that we talked about. So so you have to look into all that and not just look at the theoretical distance that's provided by the manufacturer. Security type mismatches. So this is when you have different encryptions that on the actual device, and the wrong encryption is set up on the actual device. Wrong SSID, so it might be connecting to a different access point. Wrong passphrase, so it's a wrong password. Power levels. So other than the distance limitation, there are other reasons why there might be a low power level. So you may want to get close to the WAP, avoid dead spots, turn up the power, use a better antenna, or upgrade to a better 802.11 version, typically with an N or an AC. A lot of devices actually have the radio power levels that's actually set to pretty low on the box, so you can actually change that and increase that for some of these devices. Network service issues. Names are not resolving. So this is a DNS issue, and typically if you're fully qualified domain name, when you type in google.com or something like that and it's not resolving, so then you want to check that you have the correct DNS server that's set up. If not, you can use the Google's public DNS server, which is 8.8.8.8, or your own ISP's DNS server. Incorrect gateway, so this is when the device can't communicate outside the network but only within the network, so to make sure that the router's outside address is quoted correctly. Incorrect net mask, so this is the subnet mask that's not correct. This can also be the reason why you have a bad gateway, because you're on the wrong network if you have the wrong subnet. Duplicate IP addresses, so you shouldn't have duplicate IP addresses in the network. Expired IP address, this can be an issue with DHCP. In that case, you can run the renew command or release and then renew. Rogue DHCP server, so this can be an issue where you have a rogue DHCP server that's on the network that's pretending to be a good DHCP server, and it's providing the DNS and all that information to any of the devices that are connecting. Untrusted Ssl certificate, so some of the certificates might be expiring or expired, so the companies need to maintain them correctly. So if you're getting an untrusted certificate error, then you want to check to see if it's expired. Incorrect time, so typically the time is relied on the NIST time servers, which is on the internet. So if the devices that use the NTP, which is the network time protocol servers, then there shouldn't be any incorrect time issues. But if they're not, then you'll have that kind of an issue. So you want to make sure that the devices are set up to use the NTP service. exhaust the DHCP scope. So this happens if there is the pool of IP addresses that you allocated to the DHCP server have run out. This can also happen because of a network attack where it's called the DHCP starvation attack. So you'll have to go and check the DHCP server and make sure that it's working correctly. Incorrect ACL settings and blocked ports. So typically these are based on the firewall rules that are set up wrong. And some of the common errors or issues are due to the incorrect ACL settings. And there are usually some kind of an explicit deny that's either on the direct network or on part of the network or for a range of IP addresses on that network. So if you have an implicit deny, then that's going to be for all those devices are going to be blocked out. So to troubleshoot that, you'll have to check with the IP config to check the actual IP addresses of the devices that are not able to connect. Then you go to the router and look at the router or the firewall, and then look at the actual ACLs and then see if any of those are blocked. Unresponsive service. So this can be due to an issue with the DHCP settings or a misconfigured DNS server or some kind of network configuration that's not correct with the actual services. So you want to use ping and make sure that all the devices that are needed to connect are actually there and communicating. And hardware failure can be pretty much anything, so you'll have to actually physically look at the different issues and maybe look at the network connectivity lights on the NIC and use the different physical tools to make sure that the different hardware are working.
For more details, check the link in the description. Learn with Whizlabs. Success certified.